Hey team, this is Dr. Michael McCarthy, and today we're going to talk about KNearest Neighbors. You can see I'm picking up right where I left off with the predictive tools of decision tree, support vector machine, forest model, and neural networks. And I'm looking up in the predictive space and I do not see KNearest Neighbors. So I'm going to come up to the search function that Alteryx has and type in nearest neighbors. And here it is. And I can actually drag this straight from the search space to the canvas, or I can look for that shape up inside the different tabs. I can see right here I have predictive grouping. And here it is, find nearest neighbors. And I can also drag this down. So you can see I have two inputs and both are necessary. And this is a little bit different from these others. So I'm going to simplify my workflow and clear these away. I'm going to move this up. But I need to have two flows in. And I don't necessarily know what I need here. So I'm going to go ahead and right click on the Find Nearest Neighbors and look at the help. So the purpose of the KNearest Neighbors is actually to classify data. So we have two inputs. We have data that we will use to help classify the data and the data that needs classifying. The data that needs classifying is called the query stream. We're going to ask a question about it. And then the data stream is going to help us answer that question. And it's going to help us classify it into the different types. So knowing this, I only have one data set. So what I'm going to do is I'm going to partition my data by taking samples. I'm going to use a quick preparation tool. I'm going to create samples here. The defaults here are 34 and 33. I only have 150 rows of data here. And so I'm going to go ahead and split this up. These two numbers cannot equal more than 100. I'm going to partition the data into two groups, and I'm going to go ahead and put 55% in one bucket and 45% in the other. This is how it determines the randomness of it, and this number can be from 1 to 1,000. I'm just going to select 17. And then I'm going to take this data here and have it go into the query. And of course, I will right-click, add all browses, and I have to make sure I configure this. I'm going to go ahead and select all the fields. And the number of nearest neighbors, I want to set to 2. And I'm going to go for linear search. Linear search is the most accurate, but it will take a lot of computational power. For this small data set, it works out just fine. And from here, I'm going to go ahead and run. So you can see from here, the output is actually the data classifying the query records based on the independent variables. So based on the petal width, the petal length, the sepal width, and the sepal length, it identifies this particular one as Iris setosa. So that's how KNearest Neighbors can be used to identify different variables based on the independent variables or predictive variables within the algorithm. Thanks for watching.